Have you ever pondered over what would happen to your body if you journeyed to a different planet? Well, buckle up, space cadets. Space travel, the final frontier. It's a concept that has enthralled humanity for generations. From the first moon landing in 1969 to the present day where billionaires rocket off into the cosmos for fun, the interest in space travel has only grown. It's not just about the adventure and exploration, it's also about the effects of this journey on the human body. You see, space isn't exactly a hospitable place for us Earthlings. It's a vastly different environment from what our bodies are used to, and these differences can have some pretty interesting effects. Now you might be wondering, what kind of effects are we talking about? Well, think along the lines of changes in your body mass, bone density, muscle strength, and even your perception of time. It's like becoming a superhero, but with a lot more science involved and less cool outfits. Now let's imagine you've managed to hitch a ride on the next Mars rover. So you're standing there on Mars, you step on a scale, and surprise, you've lost weight. And no, it's not because you've been hitting the gym or cutting back on pizza, it's because Mars has only about 1/3 of Earth's gravity. So on Mars you'd weigh a lot less than you do on Earth. How's that for a quick and easy weight loss plan? But before you start packing your bags for a Martian vacation, let's not forget that space travel isn't exactly a walk in the park. There are numerous challenges and dangers to consider. So, while the idea of floating around in zero gravity might seem fun and exciting, the reality can be quite different. So, are you ready to dive into the nitty-gritty of space travel effects? Hold on to your space helmets. Our next stop is the weightless wonders of space. Get ready to float through the mysteries of zero gravity and its effects on the human body. So stay tuned, space cadets, as we journey further into the cosmos. First stop, the weightless world. Who wouldn't love to float around all day, right? Now imagine you're in space, surrounded by stars and galaxies, and the blue sphere we call home is just a tiny dot in your rearview mirror. You're in a universe where the laws of gravity are on vacation. Sounds exciting, doesn't it? But there's a catch. Welcome to the world of microgravity, where your body is about to embark on a wild ride of transformation. You see, our bodies are finely tuned for life on Earth, and when we take gravity out of the equation, well, let's just say things get a bit wonky. First up, your muscles. Without the need to fight against gravity, they start to shrink. That's right, you could go to space as a bodybuilder and come back looking like you've never lifted a weight in your life. But don't worry, you'll still be able to move around. In fact, you might find yourself feeling stronger than ever. Picture trying to lift a barbell in space. You'd be the Hulk of the spaceship. But it's not all superhuman strength and floating around. Your bones are also in for a shock. They're used to supporting your weight, and when they suddenly don't have to, they start to lose density. So, while you're up there feeling like the Incredible Hulk, your skeleton is becoming more like a bird's. And not in the cool, I can fly kind of way. No, it's more like the fragile, a fall could break me kind of way. And it's not just your bones and muscles that are affected. Your heart, your eyes, your immune system, they all have to adapt to this new, weightless environment. It's a bit like your body has been transported to an alien planet and it's trying to figure out how to survive. But remember, with great power comes great loss of bone density, unfortunately. So, while we wait for science to find a way to keep our bodies healthy in space, maybe it's best to keep our feet firmly on the ground, at least for now. Next up, the not-so-sunny side of space, radiation. Now I know what you're thinking. Space radiation? That just sounds like a fancy term for a stellar suntan. Well, let me tell you, it's not quite as glamorous as it sounds. You see, the cosmos is teeming with radiation, and not the kind that gives you a golden glow. It's more like the kind that gives you a full-body X-ray, but without the cool skeleton picture at the end. It's an invisible, silent force that zips through the vacuum of space at lightning speed. Cosmic radiation comes from the sun, from distant galaxies, and from the cataclysmic explosions of stars. It's made up of high-energy particles that can penetrate deep into the human body, disrupting our cells and DNA. Imagine billions of tiny invisible bullets shooting through you. Not so fun, right? Now here on Earth, we're protected from most of this radiation by our planet's magnetic field and atmosphere. They act like a cosmic umbrella shielding us from the majority of these harmful rays. But once we venture out into the great beyond, we're exposed to the full force of cosmic radiation. Long-term exposure to this radiation can lead to some serious health risks. We're talking increased chances of cancer, damage to the nervous system, and even potential effects on mental health. It's like the universe's version of a bad sunburn, but instead of peeling skin, you get a higher risk of serious illness. And, unlike a sunburn, you can't just slap on some aloe vera and call it a day. Protecting astronauts from cosmic radiation is one of the biggest challenges in space travel. Scientists are hard at work developing new technologies and materials that can shield us from these harmful rays. But hey, don't let this deter you from your astronaut dreams. As they say, every rose has its thorns and every astronaut has their cosmic radiation. It's just another hurdle in our quest to explore the final frontier. So, next time you think about getting that natural space tan, maybe reconsider. Let's talk pressure. And no, not the kind from your boss or your in-laws. We're talking about the atmospheric pressure you'd experience during space travel. It's a whole different ballgame out there, and it's not always the fun kind. Imagine being in a never-ending pop can. Sometimes you're the fizz, all bubbly and excited due to low pressure. Other times you're the can, feeling the squeeze when the pressure goes up. That's what atmospheric pressure changes can feel like during space travel. Now, to give you a better idea, let's dive a little deeper. Here on Earth, we're accustomed to a certain level of atmospheric pressure, courtesy of the weight of all the air above us. But in space, the rules change. There's no air, which means there's virtually no pressure. And our bodies, well, they don't take too kindly to this sudden shift. When astronauts first ascend into space, they experience a drastic drop in pressure. This can cause the nitrogen in their blood to form bubbles, leading to a condition known as decompression sickness, or the bends. Picture an astronaut floating around like a shaken soda can. That's what we're talking about here. But it's not all bubbles and fizz. When they return to Earth or land on a planet with a denser atmosphere, the pressure increases. This sudden surge can cause barotrauma, a condition where air-filled spaces in the body, like your ears or lungs, get squeezed. It's like being the can that's being crushed under a foot. Not a pleasant experience, I assure you, and that's not all. The changes in pressure can also mess with your bodily functions. Your senses get dulled, your balance gets thrown off, even your taste buds go on a strike. It's like your body's throwing a tantrum because it doesn't like the new playground. So, if anyone ever tells you space travel is a breeze, you can tell them it's more like a pressure cooker. All that pressure, it's enough to make anyone pop. Well, space cadets, it's been quite a journey, hasn't it? We've traveled the expanse of the cosmos, delved into the mysteries of the universe, and explored what it really means to be a space traveler. Now it's time to summarize our interstellar adventure and bring together the pearls of wisdom we've gathered along the way. First, we have the fascinating phenomenon of weightlessness. Once we break free from Earth's gravitational pull, our bodies enter a state of perpetual freefall. Without the constant tug of gravity, our muscles and bones don't have to work as hard, and over time, they begin to weaken. This loss of muscle and bone mass is a real concern for astronauts, and it's something that space agencies are working hard to counteract. So if you're planning on becoming a celestial explorer, consider this your ticket to the most extreme gym session you've ever experienced. Next, there's the issue of radiation. Space is chock full of cosmic rays that our atmosphere on Earth shields us from, but out there, beyond the blue, there's no protective layer to keep us safe. Long-term exposure to this radiation can lead to a number of health issues, including an increased risk of cancer. It's a stark reminder that space travel is not for the faint-hearted and requires serious protection. Lastly, we discussed the changes in atmospheric pressure that come with space travel. The transition from Earth's comfortable, familiar pressure to the vacuum of space can have some pretty dramatic effects on the human body, including causing the nitrogen in our blood to form bubbles. It's a bit like opening a can of soda. And trust me, it's not as fun as it sounds. So, the next time you're dreaming of becoming the next Martian, remember to pack your spacesuit, radiation cream, and a whole lot of courage. Until next time, Space Cadets!